Hello and welcome to the fourth and final review installment for the grade 9 course. And we're looking at some geometry today. And I want you to be able to identify various geometric patterns, determine perimeter, area, and volume. So first thing I want to look at is our types of triangles. So there's a couple of things I want to look at today. The first one is kind of your three basic ones, I guess you'd say. So we have one that looks like this. We have triangle that looks like that, and finally triangle that looks like that. So those three particular triangles have specific names. The first one, because it has that square in the bottom corner, this is a right angle triangle. Right angle triangle. My second one that I drew here, because this angle is greater than 90, we call this an obtuse triangle. Obtuse, make it look like it. There we go. And finally, less than 90, this is what we call acute. A cute little triangle. Alrighty. So there's your acute. Now, there are different types of triangles as well, specific ones, which I'll put in here as well. If we have a triangle that has three equal sides with equal angles, we call this an equilateral. Equilateral triangle. If we have a triangle that has only two sides the same length, or two angles the same, we call this our isosceles triangle. And if we have one that has different lengths and different angles, we call that scalene. All right. What else can I tell you about the triangle? How many degrees are inside the triangle? The sum of internal angles. Sum of the internal angles. Hopefully everyone's screaming at their iPad. 180, Mr. Agar. Come on, say it, say it. Okay, the angles inside a triangle sum to 180 degrees. So that would mean that if I have triangle with angles A, B, and C on the inside, that A plus B plus C must add to 180 degrees. There we are. There is your review of triangles. Absolutely mind-boggling, I know. Okay, perimeter and area. The one thing I want to talk about perimeter is the distance around the outside. You'd be surprised how many people. I have no idea what just happened there. Okay, there we go. We're good. Thank goodness. Okay, perimeter. Distance around outside of object. Around outside of object. Now I'm not going to go through all the different formulas and shapes because you get a formula sheet, and if I'm on top of my game, I probably have given you the formula sheet, either paper copy or electronic copy, because you get it for tests, you get it for the exam, you get it for EQAO assessment. So no sense having you or starting you off memorizing the formulas for shapes. So you will have that at your disposal. So I guess if I had to pick a shape, let's pick something easy for me. Let's go with the triangle. So 3, 4, 5. So here is my example for perimeter and area. Like I said, you look at the formula sheet, you just got to match the shape with the formula on your cheat sheet. Very complicated for some people, but I'm sure a lot of you will be able to fight your way through. Perimeter, capital P. It's A plus B plus C is what it would be on the formula sheet. So the perimeter for this triangle is 3 plus 4 plus 5, which gives me a grand total of 12 units. Now I picked triangle for a particular reason. It's because of the formula. I was always taught it's 1/2 base times height. I don't know what that last letter was. There we go. Some people have it as base times height divided by 2. It's the same formula. Okay, so you run with the one that's most comfortable for yourself. Doesn't really matter to me which one you pick. You just need to be careful that base times height, the side that's across from the right angle is what we call the hypotenuse. Hypotenuse, which means that it cannot be base or the height. So if you have the hypotenuse, it doesn't matter which one is base and height from there. Okay, on a right angle triangle. All right, so just be careful. Just don't use the hypotenuse in the formula. So we end up with, again, substituting. So I'm using brackets. 4 times 3 over 2, 12 over 2, approximately 6 units square. And there we go. So there is my stunning example for perimeter and area. Like I said, you got all those shapes that you're responsible for on that sheet. Some of them you may not have seen in grade 8, and you'll get taught them in the grade 9 course, but for the most part, I would assume perimeter and area, you've covered a lot of those shapes already. Pythagorean theorem. I love old dead Greek guys. They seem to know a lot of stuff. So Pythagorean theorem, it is part of the grade 8 course. You see it again in the grade 9 course. There's a whole lesson dedicated to it. Pythagorean theorem, you need to identify where the hypotenuse is. Very, very important. A lot of the formulas that we use, we call this side C. The other sides are sides A and B. So from grade 8, you should know that the Pythagorean theorem is A squared plus B squared equals C squared. And depending on your teacher, some of the teachers have you memorized, the other version? That for a missing side, A squared equals C squared minus B squared. So I'm not too concerned. When you get comfortable with your algebra skills, you're going to be able to rearrange that with your eyes closed anyway. So there's your Pythagorean theorem. Remember that the Pythagorean theorem came from Pythagoras realizing that if he took a square block that was C by C, and matched it up with a block that was A by A, and a block that was B by B, that area A plus area B equaled area C. So those 3 squares, the 2 smaller ones always added up to the big one. So area A was A times A, so that's your length and width, plus B times B equaled C times C. So simplifying or using exponent laws, which we'll talk about a little bit later on in this course. That's how he developed it. Okay, you will see this. I've seen this question on EQAO, and it has a picture just like this with the 3 squares, and it'll say which one represents Pythagorean theorem, and you have to find that area, these 2 areas give me this third area. Whoops. All right, so there is your Pythagorean theorem. So you need Pythagorean theorem because we kind of mix this in with composite shapes. So I know you've done a little bit in the grade 8 course. So this picture here, let's put some numbers on it. Let's keep it simple. Make this a square, and we'll make that height there, say 5. So find perimeter and area. All right, that's the instructions. Find perimeter and area. So perimeter equals, so I'm just going to make a mark where I'm starting. So I'm going to start here and go that direction for no particular reason. So I would have 4 plus 4 plus 4, because this has to be a square. That would be a 4 plus 5 plus I need to know that length right there. So this is how we're kind of sneaky. We have you use Pythagorean theorem. So you need to find Pythagorean theorem for a triangle with a base of 4, a height of 5. What is the hypotenuse? A squared plus b squared equals c squared. 4 squared plus 5 squared is c squared. 16 plus 25 is c squared. Notice the steps. Okay, every step substitution's done properly. What's that give me? 41 equals c squared. Opposite or inverse operation, I want c by itself, so I have to take the square root of 41. And I know it's going to be 6.5-ish. I'm just going to double check. It wasn't too far off. 6.4 is equal to c. So now I know the hypotenuse, so I can finish off this question here. Plus the 6.4. There we go. Now I just got to add those together. And what do we end up with? We've got 10.4, 15, 19, 23.4 units. Now area, oops. We always do this. Area equals area 1 plus area 2. And I'm going to call this area 1, this area 2. Formula, it's a square, so L squared plus base times height over 2. So I would have 4 squared, so that's the area of the square base, plus 4 times 5 over 2. So we have 16 plus 20 over 2. 20 over 2 is just 10, so 26 units square. So there is dealing with composite shape, and the shapes, the only difference with the ones that we do in the grade 9 course are the shapes are a little bit more complicated, or you didn't talk about in as much detail. So there we are. What do I got left here? I got angle theorems. I think I'm just going to do a quick 5-second video just so I'm not rushed to finish them off, and that's it. And those should be familiar. So I will see you in the second video, and we'll finish this review package up.